I'd just like to welcome up Sergey. He's going to talk to us about peering optimization and routing security. Thank you, Sergey.
Welcome, everybody. My name is Sergey. I'm the engineer for the Gene Networks company. We're basically the software company who's doing the traffic analysis software and the DDoS detection. So we are the NetFlow collector and have multiple data sources which we can correlate to provide you with the data to make the decisions about the peering. Yeah, and as the mic tells, this is not always the very light decision or easy decision, because sometimes you need to know where the traffic flows, is there any benefits of going there, here and there, which peers to choose, and so on. And the company is based in Taiwan, so we came from afar, but nevertheless we do have a lot of customers in Europe, and our main market is the Netherlands, where we have partners and have the customers to detect the DDoS attacks and make the diversion to the cloud. So today I'm excited to talk about the common network operator tasks. What can we do as the network engineers and operators, and how our software or similar software can help you to make your daily job easier. So the first task is the peering evaluation. Which data can we use to evaluate our peering relationship? What type of peering policies should we imply to make our business better and more efficient? And how to align our decisions with the real network data we do have. The second task is the network traffic optimization. Nevertheless, we might have the peering policies in place and peering established via various IXs or PNIs. We need to make sure that the traffic actually comes through that directions. And as the previous speaker said, this is not always the fact, because nevertheless we might peer with the, let's say, Google through the LINX. They might send traffic to us via different IP transit providers. So the network traffic optimization is there to ensure that the traffic coming through the needed path, the path we want to, and our policy or BGP settings are making an effect, and the traffic is really going to the direction it's intended to do. The next one is the route health monitoring. The networks are driven by the people. People make mistakes, so sometimes we might have the instabilities or various route flapping, peering flapping, faulty transceivers, interfaces, and so on. So as a network operators, we want to make sure that the networks works as expected, and the peers are stable, nobody injecting the wrong roads to us, and RPKI validation is still in place. And the last but not least, the DDoS detection. We are living in the very changing world right now because of various geopolitics and other things. So we see that DDoS landscape is changing, and I will have a couple of slides about that later on. So the question, to peer or not to peer? What are the various peering policies available? The first one is the most obvious, no peering. So sometimes we cannot peer with the network we want, and we must buy IP transit. This is mostly related to the smaller ISPs who cannot afford making the links to various IXs and must buy just the IP transit. The next one is the restrictive peering. This is mostly implied by the Tier 1 ISPs, which want to sell transit. And by the definition, they usually have the very good connectivity to the CDNs and the rest of the world. So they don't want to peer because it will cut their revenues. Next one is the selective peering. This is usually implied by the CDNs and content owners, and they are willing to peer generally, but to peer with them you must satisfy a couple conditions. And the last one is the open peering. So the smaller networks usually also imply that they want to peer with everybody, they can. So it allows them to save on the transit costs. And we can think of it as the analogy like entering the club, right? So the open peering is the club that welcomes everybody, if they have some etiquette rules and so on. The selective peering is the club which has the doorman on the door. So you must maybe show your ID or comply with the dress code and face control. And the restrictive peering is really exclusive club which has the which welcomes only the celebrities and very famous people. So you need to bring some value to the members to be let in. The use case. How do we understand that we need to peer with somebody and how we select the peers to make the connection with? First of all, we need to find ASNs with significant traffic volume, and we usually sort in the origin AS traffic by the volume of either outgoing or incoming traffic, depending on what type of network you're running. Next, we need to assess the traffic balance, how much traffic is going from my network, how much traffic is going to my network. And next, we need to assess the costs. What are the cost implications to connect to the particular network? Do we need to buy the transit to the point of presence where that network present, or maybe we need to satisfy other requirements? And this is an example what we can show you as the net flow collector to make the informed data-driven peering decision. So on that picture, you can see the traffic that comes to my network sorted by the volume of the information that coming from different ASs. I believe most of you have similar tools in place, and this is about the convenience and various usability features, how to use that and how to make those decisions. So the next task is the network traffic optimization. Sometimes the traffic chooses the wrong paths, either because of the errors in the BGP configuration, or because, I don't know, we do have unequal traffic through our very large network. So correlating the information from the BGP with the flows allows us to enrich the flows and understand which traffic going there. And sometimes we can find out the overloaded interfaces, or we want to shift some part of the traffic to other exit links, and to make the informed decisions which part of the traffic we want to shift, which prefixes contributes most to the particular neighbor or link utilization. We can use the flow information to make the correct decisions. The next one is the BGP route health monitoring. So the networks might be unstable sometimes because of the faults or equipment failures. So how to detect those, and what metrics can we use to make the alerts and warn the network operator about some faults in the network? We can use the BGP monitoring protocol to identify the unstable prefixes or unstable peers and various oscillation of the traffic. So we can identify problematic peers and track the failure counts to make an intervention, to maybe reconfigure or change the equipment or replace the faulty transceiver. And sometimes those faults are very plausible. So we can see various faults one day, and then for the whole week, it might work well, and then the failure might return. So having the stats and various events in the monitoring system, we can identify the faulty path and shift the traffic to the other links, for example. We can also use the software to verify the route origins. So if somebody announcing the routes they shouldn't announce, and RIPE is pushing the RPKI policies, which is very good for our networks. So we need to monitor that and also understand which routes we are receiving from the peers. Here on that slide, you can briefly see the various metrics which we can use for detect various faults, like peer flapping, route flapping, prefix instability, and excessive announcement. And the last topic I want to cover in that talk is the DDoS trends. We do see the tremendous amounts of DDoS attacks last year. And as you can see on that slide, almost 4 times increase in the DDoS year over year. Recently, at May 12, we have seen one of the largest detected DDoS attacks in history, which was destined to the Krebs zone security. And the attack volume was more than 6 terabits per second. And the attack volume was extremely short, like less than a minute. On that slide, you can see another example of the attack, which was detected by the Cloudflare. And the attack volume is 6.5 terabits per second with a very short volume, less than 1 minute again. So those attacks are the real challenge for the systems that detecting attacks out of the path, because it takes a couple dozen seconds to detect the attack, and then you might advertise the route and the attack is gone. So this is really devastating, might be really devastating for the networks. So we see the rise of hypervolumetric, very large attacks. And at the autumn 2024, we've seen the advertisement in the dark market that allows renting the botnet for a whole day at the rate around $200 per day. And the botnet is capable of generating 2 terabits per second attacks. So this is dirt cheap. And to defend from those attacks, we must make measures that requires us to invest a lot more to do something with those attacks. So we see the guns are loaded, and we see the new botnets like the one that was used to attack the Krebs zone security, which is called iSur botnet. This is Mirai botnet clone, and security analysts believe those events, sub-minute, very large attacks, is just the training exercises. So just imagine the attack of such a volume that might come to your network someday. So nevertheless, it all sounds very scary, and I don't want you to be scared a lot. What we can do with that? So what are our DDoS mitigation strategies? And I believe no single network can deal with those attacks and with those points by itself. So we strongly suggest you to collaborate, to share the information, to attend the meetings like that, and discuss what are you seeing, what can be the next steps, how can you collaborate to deal with those attacks. What we're seeing also is the IXs starting to implement anti-DDoS solutions, which wasn't seen like a couple of years ago. And there are cloud scrubbing companies who can help you with that if your uplinks are saturated. And we will partner with such a company from the Netherlands, which is called NBIP Neves. And we see that a lot of clients can shift traffic towards them to deal with those attacks. And it might be an effective solution. So I believe the correct answer to that question, what can we do? We must prepare, and we cannot afford to be blind. So first of all, we need to understand what's going on, to monitor our networks, to monitor the flows, to understand which type of the attacks we are experiencing, and to make the informed, data-driven decision, how can we resist. And I believe nowadays we cannot resist just by ourselves, so we need to be prepared, make a list of the emergency contacts to know who should you call in case you experience such a large, devastating DDoS attack. You might prepare the list of the BGP communities to at least black hole the traffic. And this is the most simple and usually free method to make your network survive such an attack. In cost of the service becoming unavailable, of course. Some IP transit providers or even IXs might provide you the flow spec capabilities. So you might advertise the flow spec rules and not just black hole the traffic towards the attacked host, but deal with it in a more intelligent way. So for example, Krebs zone security attack was the attack with the randomized destination ports. So if your service using only HTTPS port from outside, you might easily block all other ports with the flow spec on your upstreams. So collaborate, communicate, understand what your uplinks, what your IXs, what your peers can do for you. to mitigate the attacks and be prepared. So key takeaway. I briefly discussed the peering evaluation techniques, how the different sources of information, like correlating the flows with the BGP, can help us to make the informed, data-driven peering decisions. I briefly talked about the route health monitoring and traffic optimization to make sure that our peering policies are in place and not violated. No peers are misbehaving, and we are receiving only expected traffic from the particular sources. And the DDoS detection and response. Be prepared, communicate, and attend events like that. So I want to thank you, and maybe you do have some questions.
Any questions? So we got one come online, yeah. The question is, what was the cost you quoted for 2 terabit botnet hire? The stream blipped for me. So yeah, you mentioned about the hiring a botnet. There was a price that...
Sorry, who's talking? I'm not seeing the...
No, it was online.
Okay, okay. So could you repeat, please?
Yep. So the question is, what was the cost you quoted for 2 terabit botnet hire?
Yeah, I've seen the information, and it's publicly available on the internet, that the cost of the whole day hire for the 2 terabits per second botnet in the darknet was like less than $200 per day. And the other figure was $600 per week. Yeah, and the botnet, as I said, capable of doing 2 terabits per second. That was in advertisement. Not sure if it's really capable or just in marketing. But nevertheless, the figure looks scary.
Scary, yeah. Okay. Brilliant. Any other questions for Sergey? Okay, thank you very much.
Yep, thank you. Thank you for having me.